When industrial machinery malfunctions, returning it to normal service quickly is essential, but you have to know what the problem is to fix it. And diagnosing equipment problems efficiently requires systematic troubleshooting techniques. In this program, we're going to look at a troubleshooting method that's often used in industry, the 6-step method. We will examine each of these steps in detail. First, investigate the symptoms. Second, identify the possible causes of the symptoms you have found. Test to eliminate possible causes until the immediate cause is found. Identify the root cause. Repair both the immediate cause and the root cause. Test the system and document what you've done. This 6-step method is a practical way to locate the immediate cause of a problem, and it reminds you to determine the root cause or the underlying cause of the problem to keep it from recurring. Very often, that is extremely important. Before we go into detail about the method, there are two very important matters. The first one is safety. Remember that any time you're working around energized equipment, you must know and follow the correct work practices and procedures for the specific machine. If there is any danger of exposure to hazardous materials, make sure you know the proper procedures for working with or around those materials. Or if during your work, any part of your body may be put in danger from machinery movement, or from electrical energy, or from any other energy source, the correct lockout procedures must be followed. If the work you are doing requires the equipment to be energized, you must be properly trained and qualified to work on the machine while it is energized. The second thing to remember is that it's much easier to troubleshoot a machine if you know it thoroughly. The more you know about a machine or about a system, the easier it is to recognize specific symptoms and relate them to possible causes. If you don't know the machine well, or perhaps even if you do, you might want to review the documentation available for the equipment. This could include drawings and schematics as well as manufacturer's manuals, which often contain troubleshooting tips for common problems. The system's maintenance records may contain useful information about the history of a specific piece of equipment and how its problems were solved in the past. Now, perhaps you've seen experienced people called out to troubleshoot a machine, and it seemed as though they found the problem just by looking at the machine as they walked up to it. But even in a case like this, a good troubleshooter is still following the 6-step method. For example, suppose that in the past, structural bolts on a machine have loosened, allowing two shafts to bind up. A troubleshooter who knows the history of the machine already knows where to look for symptoms. If he looks at those bolts as he walks up to the machine, he can save himself a lot of time. Within minutes of arriving at the machine, he's not only ready to fix the immediate problem, but he's ready to tackle the root cause as well. This is the way troubleshooting should be done. The more experienced you are and the better you know the system, the more likely it is you'll be able to proceed very rapidly through the steps. Our troubleshooter looked for symptoms at the mounting bolts. A quick test confirmed they were loose, and he could immediately start thinking about what caused them to loosen, so he could fix the root cause. Some troubleshooters can proceed so rapidly that it seems as though they're skipping steps, but they are not. Based on their knowledge of the equipment, they are examining the symptoms they find, using that information to develop an idea of a possible cause, then performing a test to confirm it as the actual cause of the problem. It may seem like intuition, but if you examine it, good troubleshooting always involves a systematic approach. All right, now let's examine the 6-step method in more detail. Step 1 is to investigate the symptoms of the failure as thoroughly as you can. Usually what you'll be looking for are things that are not working at all and things that are not working the way they should. However, and this is often the case, you can also learn a great deal by noticing what is operating correctly. Many failures will leave parts of a system operating. Taking note of those parts that are operating normally can help you establish the scope of the problem. But bear in mind that just because a device is working does not mean it's working properly. Very often, the hardest to find problems come from a device you examined and thought was normal. For example, would you assume that a pump's impeller is turning just because the shaft is? What if you later found half a dozen broken pieces of an impeller lying in the bottom of the system trap, along with the loose bolt that broke it apart? Be especially alert for concrete physical evidence of problems that may conflict with instrument readings. For example, if a machine smells hot, it probably is, even if a temperature indicator says it's okay. The indicator may be malfunctioning. Remember to use all your senses. You may feel heat or vibration. You may hear a bearing chatter. You may see a shaft wobble. Pay particular attention to those conditions which are clear indicators of a problem. Drips and leaks, burn marks or other evidence of high heat, parts which are visibly worn or broken, or even missing completely. There may be other indicators that are less obvious. For example, stay alert for any signs of repairs made to the equipment. Indicators such as clean, shiny new parts tell you work has been done on the system recently. If you see any, find out why a repair was made or what exactly was altered. It may also be a good idea to ask the operator about recent changes. This could be a process change, a raw materials change, or even a change of suppliers. Often, the operator is the best source of information about unusual machine behavior at the time of the malfunction. When you are faced with very complex systems, your search for symptoms may be more thorough if you can mentally divide a system into categories. Here's a 4-part division that's often helpful. First, the power supply. This could be electrical service, air for pneumatic systems, or hydraulic power. The basic question to ask is, do you have the required power available? Next, control devices. Are they working the way they should? Problems could be anything from a failed interlock in an electrical system to a malfunctioning pressure relief valve in a hydraulic system. Third, power transmission. This would include such things as chain drives, belt drives, pumps, motors, or any device which moves the fourth and final section, the load. This would include the objects being moved or fluids being pumped. In general, the load is the work being done. As an example of this approach, let's suppose you've been called in to troubleshoot a conveyor belt that's stopped and won't restart. You may find you have no power, and a tripped circuit breaker will have to be reset, either by yourself or perhaps by an electrician. When you consider control devices, you remember that the conveyor has an emergency shutdown system, which could certainly keep it from operating. When you consider power transmission devices, you find a sagging chain drive which may have slipped a sprocket. Or the problem could be in the load, which is loose sand and more difficult to control than, say, bagged sand. When you're looking for symptoms, consider how the symptoms relate to each other. Symptoms are any deviation from standard operation, and they happen for a reason. If you find several related symptoms, a clearer picture of that reason or cause will emerge. Determining how symptoms are related is the foundation of Step 2 in the 6-step method. Try to think of one possible cause that would link all the symptoms. For example, let's say the conveyor is down, repeatedly tripping its overloads. The symptoms you find are a series of rusty idler rollers, a leaking gear reducer, and a hopper with a damaged side apron that leaks sand down around the tail pulley. All these symptoms seem to indicate that increased friction and drag on the conveyor has overloaded the motor. Sometimes, of course, all the symptoms you find may not be contributing to the problem, and really that's not surprising. An investigation of most systems will almost always reveal conditions that look bad, but later turn out to be unrelated to the immediate problem. For example, this drive chain is so rusty and loose that it looks like a prime candidate for some kind of malfunction. Nevertheless, for the application, it works just fine. If you cannot think of a single cause for all the symptoms, you should list all the possible causes for each symptom that you've found. Now, often, of course, you will do this in your head, but if the system is very complex, or there are many symptoms and many possible causes, you may want to jot them down. If you find a possible cause that is common to several symptoms, it is very likely the cause of your problem. Or you may find that more than one possible cause is common to several symptoms. In either case, you'll want to proceed to Step 3 in the 6-step method, testing. Even if you only have one possible cause in mind, before you start replacing parts, you should determine that what you believe is the cause is really the cause. In those situations where several possible causes may be the source of the problem, you should proceed to test in one of two ways: the series method or the half-split method. Most of the time, when you're troubleshooting mechanical problems, you'll use the series method. This is especially true if you have only a few possible causes. Series testing simply means that you will test one possible cause after another until one of them is confirmed as the direct cause of the problem. If one possible cause seems a little more likely than the others, you might want to test it first. But use some judgment, especially if there are other possible causes you could test more easily or quickly. The half-split method is generally used to troubleshoot problems for which there are many possible causes, particularly in complex or unfamiliar systems. When using the half-split method, the first test you make should be one that will eliminate about half the possible causes. Let's say, for example, that you have contamination in a large, complex piping arrangement. The contamination could be coming from many possible points, so each must be considered a possible cause. You could test each one individually, but that could take a very long time. Instead, you should test at some approximate midpoint in the system. This will determine whether the contamination comes from this portion of the operation or that portion of the operation. If the test reveals contamination, then this portion of the operation is functioning correctly. The problem must be occurring in that part of the operation. Then use the half-split method again and choose a midpoint in that part of the operation for your next test. Using the half-split technique allows you to find the cause of a problem quickly with a minimum number of tests. Once you've found the direct cause, you should try to determine why it occurred. In other words, you should try to identify the root cause of the problem. This is step 4 in the 6-step method. Unless you find and correct both the direct cause and the root cause, there's a good chance the problem will occur again. For example, suppose the direct cause for this conveyor stopping was a frozen bearing, but the bearing seized because of a bent motor shaft. The bent shaft is the root cause. If you install a new bearing without straightening the shaft or replacing the motor, the new bearing will also fail. This is real troubleshooting, finding out whenever possible why the machine failed so the failure won't happen again. Anyone can replace parts, but if the new parts fail, you know you missed the real problem. The 5th step in the 6-step method is to correct both the direct cause and the root cause. Obviously, the direct cause will have to be repaired immediately if the machine's not running at all, but when and how the root cause is corrected often depends on several factors: productivity demands, how long until the next scheduled maintenance, the time required to make the necessary repairs or replacements, and the likelihood of a repeat failure if the root cause is not corrected immediately. Let's take the example of the bent motor shaft that wore out a bearing. If you cannot get a new motor until tomorrow, and you are under the demands of a production schedule, you might be willing to install a new bearing so that the machine can run until the new motor arrives. Even though the new bearing is being damaged and will have to be replaced again, it may be much cheaper than the lost production. Generally, however, you should correct both at the same time, and you should seek advice before allowing a root cause to go uncorrected. Once the direct cause and the root cause have been corrected, the last step in the 6-step method is to perform a final test of the system's operation before returning it to normal service. Be certain that all guards are in place and that all personnel are clear before restarting the machinery. Observe the unit running. Look, listen, smell, and feel. Make whatever adjustments are necessary until you're satisfied that the unit is operating properly. Once you've released the machine for normal service, remember to document what you've done. Record the nature of the problem, what corrections were made, when they were made, and who made them. This is also a good time to make a note of any other problems you spotted that might need to be corrected at a later time. As you make notes, remember that the more detail you can provide in your records, the more useful the records will be if there is another problem in the future. In this program, we've shown you how to troubleshoot industrial systems using the 6-step method. As your experience and skills grow, you will probably be able to shorten the time it takes to restore service. The more familiar you become with the six-step method and with the equipment you service, the easier it will be for you to analyze systems and determine the cause of a problem.